Okay, we're going to talk about solving real-world math problems. Some vocabulary to know for this: inverse operation, an operation that reverses the effect of another operation. So addition and subtraction are inverse operations of each other, and multiplication and division are inverse operations of each other. Operation is a general term for addition, subtraction, multiplication, or division. Examples of inverse operations. So adding and subtracting, 4 plus 1 equals 5, 5 minus 1 equals 4. Multiplying and dividing, 3 times 2 equals 6, 6 divided by 2 equals 3. So some things to ask yourself. What is the problem asking me to do? So if I look at this problem, x minus 10 equals 30. What is it asking me to do? It's asking me to subtract, okay? Since you know it's subtraction, we're going to think about what is the inverse operation of subtraction. It's addition. Our whole goal is to get x by itself. So since we know that the inverse operation of subtraction is addition, we're going to add 10 to both sides. That leaves x alone. Our 10, this cancels out, and we're left with 40. And what we can do is go back and insert what we solved for x back into the problem. 40 minus 10 equals 30, and it should work out if it's correct, if I've done my math correctly. Okay, let's look at another one with division. It says solve for x. So we need to ask ourselves, x divided by 6 equals 9. What is this asking me to do? It is asking me to divide. What is the inverse operation of division? It's multiplication. So I'm going to multiply both sides times 6. This cancels out, and I'm left with x equals 54. If I go back and substitute in 54 for x, 54 divided by 6 does in fact equal 9. Okay, let's do some examples. Look at this first one. X plus 12 equals 24. What is the problem asking me to do? It is asking me to add. What's the inverse operation of addition? Subtraction. I'm going to subtract 12 from both sides. This cancels out and leaves with x equals 12. If I go back in and substitute 12 for x, 12 plus 12 does in fact equal 24. Look at my next problem. X minus 15 equals 40. What is the problem asking me to do? It's asking me to subtract. What is the inverse operation of subtraction? It's adding. I'm going to add 15 to both sides. This cancels out. I'm left with x is equal to 55. If I go back in and I substitute 55 in for x, 55 minus 15 does equal 40. I've done my math correctly. Okay, let's look at the next one. We have 6 times x equals 42. I know this is multiplication because if I have a number and a letter up against each other, it means multiplication. Okay, so this is asking me to multiply. The inverse operation of multiplication is division. I'm going to divide both sides by 6. That cancels out, so I'm left with x is equal to 7. If I go back in and substitute 7 for x, 6 times 7 does equal 42. Okay, your turn with some problems like this. So pause the video, solve these 3, and then unpause and we'll check it. Okay, we have x plus 151 equals 267. It's asking me to add. I use the inverse operation, which is subtraction. Subtract 151 from both sides. So x is equal to 116. If I go back in and say 116 plus 151 should equal 267, and it does. Okay, we also have x minus 657 equals 241. Okay, it's asking me to subtract. The inverse operation of subtraction is addition. I'm going to add 657 to both sides, which makes this cancel out. X is equal to 898. If I subtract 657 from 898, I should get 241, and I do. Okay, third one, x divided by 34 equals 12. It's asking me to divide, so I'm going to use the inverse operation, which is multiplication. This is going to cancel out. Okay, we're going to use our distributive property here and break our 12 up into two pieces. 6 times 4 is 24, 6 times 3 is 18, plus 2 is 20. 204 and 204 equal 408. If I go up here and I work out the problem, 408 divided by 34, I should end up with 12. So let's work that out and see. 34 will go into 40 one time. And 34 times 2 is 68. So it does work out to be 12. Okay, here's another example of a real-world math problem. Linda took $20 to the school book fair. She bought 3 notebooks for $1.20 each, and a box of pencils for $1.50, and a box of pens for $1.70. How much change should she receive? So Linda starts out with $20. She spends $1.20 for 3 notebooks each, $1.20 each for 3 notebooks, a box of pencils for $1.50, and a box of pens for $1.70. So I've got to take my $1.20 times 3, which gets me $3.60. Okay, so I've taken care of that. A box of pencils for $1.50, and a box of pens for $1.70. Add up all she spent. 6 plus 5 is 11, plus 7 is 18. Carry my 1. $6.80. And we need to know how much change she had. Here we get into some tricky stuff because you are always concerned that you're not borrowing correctly. So let's take a look and see how we would do this. Okay, 0 minus 0 is 0. I cannot take 8 away from 0, so I have to borrow. Okay, and I have to borrow all the way across. 10 minus 8 is 2. 9 minus 6 is 3. 13, 20. If I go back and I take how much of her change plus how much she spent, it should equal $20. And it does. That's one way you can make sure that you've subtracted the zeros correctly, is go back and check your answer. Make sure you've done it correctly. Okay, Mrs. Stewart had 325 chapter books to put on 13 shelves. She would like each shelf to have an equal amount of books. How many books will go on each shelf? So we're taking her total amount of books and dividing it up by her shelves. Okay, 13 will go into 32 2 times. 13 times 2 is 26. Subtract, 12 minus 6 is 6. Bring down my 5. Now, I might not know right off the top of my head what 13 times what would equal 65. But I know that if I have a number that's multiplied times 5, it's going to end in a 5, right? So 13 times 5 is, or 3 times 5 is 15. 5 times 1 plus 1 is 6. So that's a good place to start. So she'll have 25 books on each shelf. And she doesn't have any left over. Okay, Mrs. Smith had 384 pieces of candy to share equally with her 32 students. How many pieces of candy will each student get equally? Not worried about a remainder here. I want to see how much each student will get equally. 32 can go into 38 one time. 8 minus 2 is 6. Bring down my 4. 32 can go into 64 2 times. And I don't have a remainder. Anytime you have a large amount being split up between a group of people, it's going to be division that you use for your operation. Okay, the 5th grade class has a goal to walk 135 miles on their track. There are 27 5th grade students. How many miles does each 5th grade student have to walk to meet their goals? So we have a total of 135 miles split up by 27 students. Again, I may not know how many times 27 can go into 135, but I do know that if I multiply something times a 5, it's going to end in either a 5 or a 0. So I'm going to try this. 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. It actually works out perfectly. Each student would walk 5 miles. Okay, so make sure when you're reading questions that you look to see exactly what you're doing. Are you adding up something? Are you subtracting change? Are you dividing a large amount by a group of people? That will help you know for sure which operation to use in real life situations.